magical gold, fascinating gold, glamorous gold. Gold, noble, voluptuous, fashioned into works of art. Gold, conductive, reflective, incorruptible. From deep within the earth it is mined, the universal measure of value in medium and exchange. With it we pay for oil rafts, wheat, rockets, and bonds. With it we anoint our heroes. Gold is the supreme symbol of achievement, a synonym for success. As the poet wrote, gold is a child of Zeus. No moth, no rust devours it. Only the mind of man is devoured by supreme possession. We embark now on a journey of discovery to explore the process with which this most precious of all metals is arrested from the bowels of the earth. South Africa has been blessed with an abundance of gold reserves. The greatest mineral wealth lies south of the Beaconsfield in the pre-Cambrian conglomerates and quartzites of the Witwatersrand, containing the world's most important gold-bearing reefs. These gold-bearing conglomerates and quartzites extend into the Orange Free State, where they lay concealed beneath several thousand meters of Karoo beds and other sedimentary rocks. This assemblage of valuable minerals, precious metals, and stones, all within an area of a few thousand square kilometers, is scarcely to be rivaled anywhere else in the world. The gold occurs in a finely divided state, as a powder in bands of quartz pebble conglomerates called blankets, which are believed to have accumulated as shoreline pebble deposits. Archaeological evidence indicates that gold has been mined in South Africa since ancient times, dating as far back as the pre-Christian era, although only to a limited extent within the country's borders. The first historical mention of gold mining in recent times was in 1836, when indigenous tribes were reportedly extracting gold-bearing ore from a small mine in the Soutpansberg area. The first mine to be opened by modern settlers was the Easterling mine in 1871, and the original workings are now preserved as a national monument. This discovery was closely followed by discoveries in the Eastern Transvaal at Pilgrim's Rest in 1872, Kaapsche-Hoop in 1874, and Barberton in the 1880s. Even though the brothers Struben had crushed the first Wits conglomerates on 20th of December 1885, it is generally accepted that the opening of the Witwatersrand goldfields can be attributed to G. Walker and G. Harrison, who discovered and tested the rich main reef leader on the farm Langlaagte in 1886. A gold rush of unprecedented proportions followed, and hopeful perspectives quickly spread east, west, and south, as far afield as Klerksdorp, Belfer, and Heidelberg, wherever conglomerates outcropped, chasing after the elusive promise of wealth. The vigor and tenacity of those early prospectors and the giant mining houses which inevitably arose led to the discovery and exploitation of the different goldfields currently being mined. Any further extensions of new goldfields can now only be discovered through geological extrapolation and deep-level exploration. Two primary techniques are currently employed in subsurface exploration, namely geological drilling and seismic exploration. Geological drilling often constitutes the second phase of surface exploration. Exploration is now carried deeper into the Earth's crust to delineate the depth, structure, and value of a potential ore body at depths inaccessible to surface exploration techniques. In some instances, geological drilling is the only tool utilized, especially in areas where the ore body has no surface manifestation. The Free State goldfields was discovered in such a fashion, where drilling was carried out to search for gold-bearing conglomerates which were inferred and extrapolated from known gold occurrences in the northern and western portions of the Wits Basin. Geological drilling remains a very costly operation, and boreholes are usually sparsely drilled. For this reason, boreholes have to be sited with the utmost care and attention. Seismic surveys utilize waves bounced off stratigraphic layers to build up a picture of the geology deep in the Earth crust. This technique has its limitations and relies on the composition of different stratigraphic layers and resultant acoustic impedance between them. It can, however, be a very useful tool in the delineation of the structure of the ore body. Recent developments in seismology allows for the generation of a complete three-dimensional model of the ore body, which is of immense value in the understanding of the structure of the ore body. Once the exploration program is completed, the decision to mine or not to mine is based on a number of factors, the most important being financial. If the estimated revenue to be generated by the mining venture is calculated to be more than the cost of exploiting the ore body, then the sinking of a new mine or shaft may commence. The cost of sinking a new shaft is enormous, ranging from 500 million rand to 1.5 billion rand, depending on the size and depth of the shaft. Careful financial studies are carried out to determine the profitability of a new venture. These studies are done at varying gold prices, cost structures, and escalation rates. Money can be raised in different ways to fund the new project. It can be funded from within a current mining operation. Money can be raised on the stock exchange by the issuing of shares, or major investors can fund the venture. Environmental protection and preservation is also becoming a major issue when a new mine or shaft is developed. Current law requires that a rehabilitation management program be submitted and approved before the new venture gets off the ground. After the raising of necessary funds, a decision has to be taken on the site where the shaft will be sunk. These are a few factors which are taken into account when a new shaft is sited: power supply, water supply, location of housing, surface topography, surface rock formations, underground water, the geological structure of the ore body, and the distribution of gold in the ore body. Although there are no set rules for the siting of a new shaft, it is often done in a high-grade area in an effort to generate as much revenue as possible in the shortest time possible. A shaft is in effect a hole in the ground, either vertically or at an inclination through which men, material, and rock are transported. Services such as electrical cabling and water pipes are also routed through the shaft. Ventilation or fresh air, required to maintain life underground and to create a working environment, also flows through the shaft. The first step in sinking a new shaft is the preparation of the site. Major earthworks may have to be done. The upper layer of surface soils, the overburden, is removed with earth-moving equipment. Minor blasting is also required when solid rock is encountered. This stage is called the pre-sinking. Once the pre-sinking is completed, the shaft sinking proper commences. Labor crews drill holes down into the rock. These holes are loaded with explosives and blasted. The broken rock is hoisted to the surface in a bucket-like hoist called a kibble. After a portion has been sunk, the hole is lined with concrete or a competent substance. This maintains the integrity of the bedrock, preventing loose rock from falling down the shaft and injuring people working at shaft bottom. The shaft is normally sunk to a depth below the reef horizon. A network of tunnels is now blasted on a specific predetermined grid in order to access the ore body. As with the shaft, these tunnels are used to transport men, material, rock, and other items required to mine the reef. On most shafts, the tunnels are equipped with rails. Hoppers or train trucks are used to transport the reef-bearing rocks to the shaft. This operation of creating a network of tunnels is called development. If compared to the human body, these tunnels will be the arteries, with the shaft functioning like the aorta, like the arteries through which life-giving blood is transported to the body. The tunnels will be used to transport revenue-generating ore to the surface. When the first tunnels intersect the ore body, the flow of ore can start. The development program will continue to open up new reserves by exposing the reef. The operation of extracting the reef-bearing rock from the country or barren rock is called stoping. Stoping in effect entails the creation of a cavity where the gold-bearing rock used to be situated. This is done by drilling holes just below and above the reef and charging them with explosives. This crushes the gold-bearing rock, which can then be transported to the shaft. The cavity is blanket-shaped, and the host rock forms a roof above and a floor below it. The roof is called the hanging wall, and the floor, the footwall. The roof needs to be supported to keep this cavity open. If this is not done, the roof will cave in and injure people or trap them underground. The type of support used is determined by the depth of the mining operations, the type of rock being mined, the height of the cavity, called the stoping width, the seismic activity in the area, the geological structure, and numerous other factors. Although packs built with timber are still widely used, other methods of support have been experimented with over the years. Wood has become scarce due to the depletion of forests, and this gave rise to an increase in timber prices. Therefore, alternative methods of support are continuously being developed. One alternative method of support is to use the residue from the metallurgical works to fill the stoped-out area. The residue, which is in the form of mud, is pumped back underground and pumped into the back area. An advantage of this method is that not as much residue is placed on the slime dams. On some shallow mines, the roof is supported by roof bolts. This is a long piece of steel that is bolted into the hanging wall. The broken rock containing the gold is cleaned from the stope face by various methods, ranging from loading it manually with spades to the most sophisticated methods of rock loading. Most mines use winches which pull the scrapers along the floor of the stope. The scrapers drag the broken rock to an ore pass or chute from where it is loaded into the hoppers. High-pressure water jets are used to wash the rock to the loading point. In some cases, mechanical loaders called busmans are used to load the broken rock. On mines using conventional transport, the span of hoppers is pulled with electrical, battery-operated or diesel locomotives along the tracks in the developed tunnels to the shaft. Where mechanized mining is practiced, dump trucks transport the rock to the shaft. Close to the shaft, the dirt will be poured into an ore pass system. Ore passes are steeply inclined development tunnels which connect one mining level to the other. This system of interlinked tunnels continue to the bottom of the shaft. At the shaft bottom, the rock is drained from the ore pass and normally taken from the point of discharge to the point of loading by means of conveyor belts. The device used to hoist the rock in the shaft is called a skip. The skip is pulled to the surface with a winder, and the rock is transferred to the headgear bins. From the headgear bins, the rock can follow a number of routes. It can be dumped on a shaft stockpile from where it is loaded into trucks or trains for transportation to the metallurgical works. It can be taken directly into the metallurgical works with conveyor belts. It can be transferred to shaft railway bins from where it is loaded into trains or trucks for transportation to the metallurgical works, or it can be stockpiled for later use. Waste rock, that is rock containing no reef, is normally dumped on a waste rock dump via a conveyor belt. Some of the waste can be crushed to be used for the various applications of crushed rock, such as cement products or for the building of roads. Strict control is placed on the tramming and hoisting of waste to ensure that no gold-bearing rock is placed on the waste rock dump. It is also imperative that all the gold-bearing rock is removed from the stopes. The floor of the stope is swept to ensure that no fine particles, which normally contains a high proportion of carbon, is left behind. When the broken ore reaches the surface, it is trammed to the metallurgical works or plant. This is done by train, truck, or conveyor belt. The type of milling or extraction technique will determine the route that the ore will follow. In some of the older plants, the rock will first be screened to separate various fraction sizes. The larger rocks will be crushed and then sent through a series of mills together with the smaller pieces of rock. After the final milling stage, the rock will be pulverized, ultimately resembling talcum powder. In the newer plants, all the underground material will be fed into a run-of-mine, ROM mill. Steel balls are also used as a grinding medium in these mills. The rock will have the same fraction size as in the process mentioned before. Various types of extraction methods are currently in use. The process that we will focus on is called carbon in pulp, or CIP. With this method, the pulp from the milling section is pumped into huge tanks where cyanide is added. A chemical reaction is caused by the addition of the cyanide, freeing the carbon particles from the pulp. This pulp is then pumped into another set of tanks where activated carbon is added. This activated carbon consists of tiny pieces of coconut shells which have been burned and treated. The carbon in this pulp solution sticks to the activated carbon, which then becomes loaded. Thereafter, the carbon is treated in a kiln, where the volatile material is burned off, and the end product is a solution which is enriched with carbon. The carbon-rich solution is then pumped into containers where frames with electrified steel wool is placed in the solution. The carbon precipitates onto the steel wool, which is then placed into an arc furnace. The material is smelted in the furnace, and the gold is poured out into molds. The bars taken from these molds contain gold and silver and are referred to as bullion. At the Rand refineries, the silver is extracted from the bullion and pure gold is produced. Magical gold, fascinating gold, glamorous gold. Released from its virgin state, it continues to inspire and seduce man.